All right, so this is Horner, and this is the last 7 questions for 2D projectile motion. Let's go ahead and take a look at number 51. It says, what is the resultant of a 3-unit vector and a 4-unit vector at right angles to each other? So here I've got a 3-unit vector, here I've got a 4-unit vector, and then I've got my hypotenuse. So this is really just a 3, 4, 5 triangle. So this one's pretty simple. You could do the math on it. You could say the resultant is equal to the square root of 3 squared plus 4 squared. But if you know anything about triangles, you know that this is a triangle, right triangle with a 3, 4, 5 configuration. So the resultant here is just equal to 5 units. For number 52, that's the next one. It says, suppose a small plane can fly at 170 kilometers per hour. So we know that Vx is equal to 170 kilometers per hour relative to the surrounding air. Suppose also there is a 60 kilometer per hour tailwind. So I know the velocity of the air is going 60 kilometers per hour. And that's in the same direction. So I've got this vector, and I have another vector that I just add to it. This one's 170. This one's 160. They want to know how fast does the plane's shadow move across the ground. So here's the plane. Here is the shadow of the plane. Whatever the speed of the plane is the speed of the shadow. So if the plane is going 170 plus 60, that's going to be 230 kilometers per hour. So it's really just adding the 2 is all you need to do. For number 53, you have, at an instant, a ball is thrown horizontally with large force and identical balls dropped from the same height. Which ball hits the ground first? And we've done one very similar before. So I've got one that is thrown off with a very large force, so it goes really far away. Got another one that's dropped straight down, and they're dropped from the same height. So irregardless of their x velocity, remember the time is only determined for this one by dy is equal to 1/2 gt squared. So the one that hits the ground first is neither. They hit at the same time. That's number 53. For the next one, we have number 54, and it is this one. It says a cannonball is fired at some angle into the air. So here we go. In the first second, it moves 5 meters horizontally. So that would be 5 meters per second, which is actually a velocity. Assuming it doesn't hit the ground and air resistance is negligible, how far does it move horizontally in the next second? Well, we know that in this next second, it's going to move a little bit further, but once again, we're going to move at 5 meters per second. So we know we move 5 meters. We know that our v here is constant, so it does not change. And so we should have 5 meters right on the button. For the next one, which is number 55, in the absence of air resistance, at what other angle will a thrown ball go if you throw it at 75 degrees? So pretty big angle here. This is 75 degrees. Remember, the key to finding out the other angle is just take 90 minus the first angle. So 90 minus 75, this would be 5. This would be 1, so it would be 15 degrees. And that will give you the same position. So we could shoot one up at 75, it just goes really high and then comes back down. If we shoot it at 15 degrees, it's not going to go as high, but it will go over and it will land at the same spot. So this one is 15 degrees right here, the bigger one was 75, and if you add them together, they do equal 90. That's the other way that you probably need to check. Number 56, a ball is thrown straight upward at 10 meters per second. Ideally, the ball will return to the thrower's hand with a speed of 10 meters per second down, or you could say negative 10 meters per second. The magnitude is the same. So if I throw a ball up at 10 meters per second in this direction, it will come down at 10 meters per second in this direction. This ball is thrown straight up, so it goes up at 10, and when it comes back down, it hits the person's hand at 10 meters per second. So here, same thing, this would be down, and this direction would be up, but the magnitude is the same. And so because it says speed, you just need to have the 10 meters per second. And finally, the very last one, yay, is a cannon with a barrel velocity of 140 meters per second launches a cannonball horizontally from a tower. So here's a tower, and here is our cannon, and our cannon shoots. And it says how far vertically will the cannonball have fallen after 4 seconds. So it's shot with a velocity like this, and it comes out and hits the ground. So the velocity in the x is equal to 140 meters per second. But once again, we don't worry about that because we're worried about how far it falls vertically in 4 seconds. So this is horizontal. We really don't even need it. We just need that 4 seconds, and that's equal to our time. So that'd be 1/2 of 10, so 1/2 g, and then this is t squared. So this would be 4 squared. So 16 times 10 is 160 divided by 2 for our distance in the y. So your distance should be 80 meters. That is how far it would fall in those seconds. That could be here. That could be here. It just depends on how tall the tower is. If the tower was 80 meters tall, it would go all the way to the ground. So we don't know how tall the tower is. We just know that it falls 80 meters in that time. And that is the end of the conceptual questions.